This is part 2 of the solutions for test 5 in the AP Physics class in the fall of 2013. We're looking at problem 11 now. And problem 11 is a projectile motion problem. So we're going to need to fill out our table. We started out, according to my axis, he's originally located at 0 meters. He's on a cliff. His height is 85 meters. So I'm making this my axis. There's x, this is y, and this is y equals 0 meters. And he's going to eventually, the ball's going to end up down there, and the ball starts right up here. So x, I don't know where it's going to hit, but it's going to end up at a height of 0 meters. I have to find Vx naught and Vy naught. Vx naught is this side of the velocity vector. This is going to be Vy naught. I had to find that as well. Vx is going to be whatever Vx naught is. Vy, don't know. Ax is 0 meters per second squared. Ay is minus g. V naught, I'm told, is 120 meters per second. T, I'm not told. And theta is 37 degrees above the horizontal. Part A, find Vx naught. That's V naught, and I'm looking for the adjacent side of the triangle here, so that trig function A for adjacent, and A is closest to C for the cosine. So this will be 120 meters per second, and we're going to multiply that by the cosine, 37 degrees. Punch all that in, we get 95.8 meters per second. So that goes up in here. They also need to know what Vy naught is. Now we're looking for the, in Vy naught's case, we're looking for the opposite side, so we're going to use the sine function. So let me pull the paper down. Vy naught is V naught sine of theta, 120 meters per second, and you multiply that by the sine of 37 degrees, so that comes to be 72.2 meters per second. And of course we'll go and put that back in our table up here. We still don't know that. So if you look at our table, as always, we have 3 unknowns for a 2-dimensional projectile problem, and we have 4 equations. We always have one more equation that we have unknowns. The second extra equation can act as a check for us. Let's see what they actually ask us to use that table to find. They ask how long will it take to strike the level ground at the base of the cliff. Okay, so to work that problem, I have y is equal to y naught plus Vy naught t plus 1/2 ay t squared. The final height is 0, so I have 0 is equal to minus g over 2 t squared plus Vy naught t plus y naught. So that's C, that's B, and this is A. So this is of the form AT squared plus BT plus C. Just like we did in the exam number 4, we're going to use the quadratic formula. T is equal to minus B plus or minus the square root B squared minus 4AC over 2a, but we also have the condition that t has to be greater than 0. When we put that in and taking the correct and only one root that meets that criteria, we get that we have the following, that it's Vy naught plus the square root of Vy naught squared plus 2gy naught divided by g. We put our numbers in there. 70.2 meters per second. I believe that's what I had previously up here. Let's see. Yes, that's correct. Plus the square root of 72.2 meters per second. We're going to square that. Plus 2 times 9.8 meters per second squared times y naught, which was 85 meters. All of that divided by 9.8 meters per second squared. And we punch that calculator and we find that the object has been in the air approximately 15.8 seconds. Okay, now next part of the problem. How far from the cliff will it strike? Well, it turns out that this is pretty easy part of the problem because we know the speed in the x direction and the time that this projectile is in the air. So x minus x naught is vx naught times t. X is approximately 95.8 meters per second, and it's in the air approximately 15.8 seconds. So the distance that it travels is approximately 1,510 meters, at least to 3 sig figs. Part E. What is the speed of the projectile just before it hits the ground? Now in this case, you've got a little bit different problem. We know Vx, the x component of the velocity. It's equal to Vx naught, and so that's just approximately 95.8 meters per second. We also need to find the y component of the final velocity, which is Vy naught minus gt, which is approximately 72.2 meters per second, minus 9.8 meters per second squared, times 15.8 seconds. So the y component of the velocity is approximately minus 82.6 meters per second. So we've got something that's 95.8 meters per second. It has a y part of 82.6 meters per second, and I'm looking for the hypotenuse, and this of course is a right triangle, so I'm looking for v. V is the square root of v x component squared plus the y component squared, so v is approximately the square root 95.8 meters per second squared plus 82.6 meters per second squared. So the velocity is approximately 126 meters per second. Or I should say the velocity, the speed, the magnitude. And that finishes problem 11. Now problem 12 is not nearly as complicated a long problem. It's just a one-dimensional problem. And it says a kangaroo can jump vertically upward with a speed of 13 meters per second. Alright, so goes upward, Vy equal 13 meters per second. That's Vy naught. Goes up to from y naught equals 0 meters to some height y equal whatever. And here Vy is equal to 0 meters per second. So y naught 0 meters. Y don't know. Vy naught 13 meters per second. Vy 0 meters per second. Y is minus g, and t you don't know. One-dimensional problem, two unknowns, three equations. To find out how high they get, you have Vy squared is Vy naught squared plus 2 times minus g times delta y. final velocity is 0. So delta y is equal to v y naught squared over 2g, which would be 13 meters per second squared over 2 times 9.8 meter per second squared. And you punch that in and you get 8.62 meters. So that's just a second. That's what the height happens to be. Alright, in the next video I'll deal with the bonus problems.